Приветствую вас. Приятно видеть заинтересованных лиц, которые заинтересовались данной тематикой. Отлично, что вы хотите разобраться в этом направлении. А самое классное то, что вы задумываетесь, что производственные сети нужно также защищать. Моя часть презентации — это буквально, я не буду отнимать совсем, там, я немного времени отниму от времени Винсента, потому что я очень хочу, чтобы Винсент на практической плоскости показал, как можно закрывать уже проблемы по промышленным сетям. Моя миссия буквально вам показать, что такое промышленные сети и чем они отличаются от IT. Итак, заблуждение говорить о том, да, что там в IT-сетях и в OT-сетях, OT-сетях — это производственные сети, они так сокращенно называются, ну, могут называть и АСУТП, и ICS, и SCADA, различные названия. В общем, принято ОТ. Значит, не вникая в специфику архитектуры, говорят, что они подобные, да. Я поэтому вот сразу вас заинтересовать интересным слайдом. Это, собственно, архитектура, выработанная годами, различными стандартами. Архитектура называется модель Purdue, которая описывает, как должны строиться, в общем-то, АТ-сети, да. Вы на экране видите, тут достаточно большой разнос, да, тут есть какие-то сенсоры на низком уровне, какие-то исполнительные устройства, есть повыше уже сервера, есть уже сервера, там, которые вам известны с IT-инфраструктуры, какие-то финансовые приложения и так далее. Поэтому отличия есть, естественно. И на это, понятное дело, обращают внимание сейчас в первую очередь, потому что вы прекрасно там знаете, различные проходят новости по критической инфраструктуре в различных странах, происходят различные атаки на эти инфраструктуры, и если в IT-сетях, как бы не обижайтесь, товарищи айтишники, которые здесь есть, я сам, в общем-то, с этого начинал, да, то остановка каких-то сервисов может повлечь за собой какие-то финансовые риски, ну, в основном, да, то остановка или какой-то саботаж АТ-сетей может за собой повлечь, очень неприятные вещи, связанные со здоровьем и жизнью людей. Даже на уровне вмешательства в структуру информационных потоков. Поэтому вот есть организации, да, есть директива, которая там больше закручена на странах. Есть стандарты, вот как пример один из них, который регламентирует, устанавливает принципы и, собственно, в которых прописаны основные там истины по, опять же, отличию взаимодействия ОТ-сетей с IT-сетями. Ну и понятное дело, что краеугольный камень во всех этих системах это, видите на экране, да, это всегда конфиденциальность, доступность, целостность. Так вот, в IT конфиденциальность в основном, да, мы говорим про основную модель, она всегда наверху, целостность, доступность важна, но она не столько критична, как конфиденциальность. В OT-сетях это совершенно наоборот. Ну, как бы с этого все и начиналось, да, по тому, когда была попытка понять отличия этих систем. Дальше, как бы на основании тех стандартов, директив, которые там я раньше вам показал, вылилась примерно такая табличка, да, которую я тут немножко тоже сам дополнил и там использовал там материалы со стандартов. То есть в чем же все-таки отличие? Ну, то есть в IT-сетях фокус безопасности идет на информации, на базу безопасности серверов конечных точек. В АСУТП это контроль промышленных устройств, физических процессов – это безопасность труда, да, о чем я говорил. Жизненный цикл технологий в IT 3-5 лет, ну, плюс-минус, да, в производственных сетях до 20 лет и выше. То есть есть вещи, которые построены там даже в 80-х годах и до сих пор используются. Вот. Пример, да, по антивирусу, да, то есть, ну, мы можем в IT ставить это, в общем-то, правило хорошего тона, а вот в производственных сетях это довольно-таки сложно реализовать. Значит, установка патчей то же самое. Регулярно по расписанию, понятно, мы там проверяем их на каких-то тестовых средах. В АТ-сетях это редко и связано с очень непростыми технологическими процессами, поэтому это все очень болезненно воспринимается. Аудит и тестирование, ну, в IT мы уже привыкли, там, если хотим более качественно, то привлекаем третью сторону, а в случае с ОТ, то время от времени после сбоя, опять же, связано с спецификой того, что системы работают четко в реал-тайме. Время отклика не критично, а в ОТ-сетях задержка времени, так как реал-тайм, может быть и случаем нарушения безопасности, и ну, может даже привести к какой-то катастрофе, как локального уровня, так и глобального. Решения по информационной безопасности, да, разработаны для стандартных, да, ну, для типичных систем, интегрированы бывают. А в ОТ-сетях инструменты безопасности должны быть протестированы, чтобы убедиться, что они вот не ставят под угрозу как раз процессы СУТП, которые вот у нас происходят в нашей производственной сети. Коммуникации, да, это стандартные IP-сети, а в ОТ-сетях это дополнение к стандартным IP-сетям. Есть еще специальные, их очень большое количество проприетарных протоколов, которые используют вот эти устройства с АТ-сетей. Этот пункт, основные участники, да, вот этот пункт, основные участники в IT, да, это SEO, это там системные администраторы, разработчики, девопсы, и как бы, как смеются некоторые разработчики стандартов, это молодое поколение, да. В ОТ-сетях все кардинально наоборот. Тут, скажем так, закоренелые производственные инженеры, там, директора производства, которые очень консервативные, и поэтому тоже накладывают свой отпечаток при разработке там какой-то программы по безопасности. Но здесь есть такой, сейчас появилась такая мостик такой, да, взаимодействия, называется, ну, вы прекрасно все знаете, я думаю, некоторые из вас уже активно этим пользуются, интернет вещей. То есть различные датчики, различные контроллеры, там, проветривание комнаты, ну, там, включение-выключение света и так далее, и так далее. Это все пришло как раз вот с ОТ-сетей. И в том смысле, что как бы, ну, вот есть надежда, что молодое поколение и конгломерат поколения постарше, этот вопрос, ну, и этот пункт у нас исчезнет. Локация в IT основные компоненты, а тут они изолированы, к ним сложный доступ, в очень сложных условиях могут работать. И поддержка, да, тут можно ну, как бы универсально подходить к поддержке, тут строго поддержка от одного поставщика. Вот это вот основное, на мой взгляд, отличие IT от сетей для построения ваших программ. Дальше как бы, ну, это уже вам покажет сейчас уважаемый Винсент, интересный вендор, интересные решения, вот. И про TrapX вы можете увидеть уже на моих предыдущих сессиях. В принципе, у меня все.
Заказать у тебя демонстрацию с презентацией.
Да.
Коллеги, тогда передаем слово.
So if you look at 6443-3, which is zone on conduits, everybody has firewalls at the perimeter, but usually there's no protection inside. You know, downstream inside the plant, it's very much of a flat network. So OT Fuse can be used to really protect all these devices, all these assets which are totally unprotected. In IT, people always talk about operating in a zero trust environment. On a control network, it's total trust. Devices trust each other and will take a command on a program from anyone. And this is what OT-Fuse is there to answer, to really protect unrecognized sources from addressing the protected assets or blocking the illegal operations. And that might be using a different protocol than what is expected or a different subset of command. The device can, for example, enforce read-only policies or read-write and preventing reprogramming, for example. So now I want to show you the demo system. So we have an OT-Fuse and a Windows console, and then we have a Rockwell HMI talking to an Allen Bradley PLC, and we have a Modbus client server system talking to each other. And I just want to switch to the application. So we are running the OT-Fuse console. We have security dongles, and we can manage it that way. There's also the ability to manage the device from a central management, to have many devices all managed from one central station. And in that case, we're using, a certificate authority. If you look at, that's a brand new device, and like you would get out of a factory, except just added the license. And the idea is we're operating at layer 2 transparent bridge, which means we are invisible on the control network. We just plug the device in, and your switch is to learning mode. Here we're going to learn the relationship between the traffic going in the system, who is talking to whom, what protocol do they use, what kind of commands do they use. So it should take maybe 30 seconds to start getting some information coming here through the traffic I have. So you can see I've got some Modbus traffic, and that's all access. And I've got mod traffic here, which is read only from an Allen Bradley HMI. So if I go into monitoring mode, that is anything which is not part of this LAN policy, and I've got the ability to modify it. I'll show you in a second. But here I've got the ability in monitoring mode to create event. Anything not learned here will create an event. So if I go to my Allen Bradley HMI, I'm going to start my pump. So that's going to create a write event, right? Am I writing to the PLC to change the status of that pump? So that the operator goes in, and if I go back into event, you'll see I've got some Allen Bradley event. I also have some Modbus, but I've got an Allen Bradley event here. I can acknowledge, and you can see I try to write a tag. And what I'm going to do, I can say, yes, that's something I would have liked to block because the station is a read-only station. Or actually, in this case, well, the operator is allowed to make a write event. So I'm going to update the policy. I'm going to save that. And if I'm going into the system, you're going to see the policy has been, if I go to the dashboard and look at the event, the policy has been updated to value read-write. Now, it does not allow that station to change the program on that PLC, but I can actually go read and write. So that's an example of what we are doing here in terms of event being generated. We have a little graph here. Let me recenter that. I've got a small screen. So you can see I've got two systems. I've got a whole access on Modbus from these two systems, and right now they do not intersect, right? I've got value read write on the PLC. Now what I can do here is my Rockwell HMI. I also have a Modbus client. So what I can do is I can go talk to the Modbus device as well. So first of all, I'm going to read some registers. Let's start reading. And it's reading temperature and humidity. Every few seconds, it's getting updated. And I can also do, I can also write. And actually, what I'm going to do is show you an example of enforcement. So right now, I'm doing a read. And what I'm going to do, I'm going to go into protect mode. And I'm going to show you that in protect mode, my write will be denied. Actually, if you see on the graph here, I've got some red. So you can see there's an event related to that device, because right now I did a read from here to there. So it does not be allowed, so it's not part of a policy. But you can see there are events to review. And I'm going to review them all at the end. So now in protection mode, what I'm going to do is I'm going to try to do a write. If I do a write command, obviously I'm not allowed to communicate, right? I haven't been allowed to communicate, write multiple registers. Okay, and you see the write has been denied. I'm not allowed to write anything here, okay? And the read was denied as well because I am in protection mode and I've got event, so I can't even read data right now because I'm in protection mode. If I go back to my HMI and look at my event, I will have two events. I've got a Modbus read and I've got a Modbus write. And what I can do is for both events, I'm gonna accept them. So you see I can accept, so I tried to do 7 reads. And I read these particular registers. In that case, it's telling me exactly what happened and where it's coming from, where it's going. Okay, and I'm going to acknowledge also the write event that occurred only once. And I just say, just add to the policy. So now I'm learning all this, even from in protection mode or in monitoring mode, I'm adding to it. These are normal operations for the plant. And if I look back at my dashboard, so I'll have an extra line of policies, right? And that should not be updated that way. I should have a table showing me that, oh, it gave me all access. So maybe I've got some action I shouldn't have done. But here I also have the ability to go back to idle mode and I can manually edit these connections. So for example, from here to there, I don't want all access. I can say I want actually, we have an advanced policy when I can actually limit which registers can be read and written. So I can say I don't want any write at all, just read. And only these limited registers can be read. For example, 0 to 5 and 20 to 30 would be allowed to be read, actually, 20 to 30. So this would be a very detailed policy where not only I limit the command, but also the level of registers, which would be allowed to be read or written to be accessed through our protection device. And again, we also have the ability, to protect, to change these policies on a temporary basis. If, for example, this HMI station was used also for engineering, and we know we have an outage planned next week, I can go in and say, well, I'm going to change to full access so that I can do engineering, and only that's going to be taking place next week. Okay. And in that case, I can have temporary escalation of privileges. Just, it is pending. It's not active right now. We still have our value read write policy active, but next week they'll temporarily have extra privileges, and we'll go back to normal. So that is really the purpose of the OT Fuse device. We have also a central management console. Let me give you a quick preview of that. And I've got my secret username and password. And you see we've got 4 events. It's exactly the same event we have seen earlier directly from the device. We can see them from here. I can manage all my appliances. In that case, I only have 1, so it's easy. But everything we did directly from the appliance, from the web interface, we can do from here. For example, changing the mode of operation, updating the software. We can do all that directly from here, looking at the policies. It should be, hopefully it's the same, right? And all the setting can be done this way. So that's really the purpose of the OT Fuse. It's meant to be a cabinet level protection at the device level, and really at the cabinet level. That's really the purpose of OT Fuse. So now what I would like to show you is a different protection, and that's really at the level of the net wall. So net wall is really a unidirectional gateway, and that means its purpose is to get data out of a plant very safely with nowhere to get any communication back. So this is not a network connection. You have 2 isolated networks, and you have a non-networked way to transfer data. So it's a true unidirectional gateway. It is using a technology slightly different from the data diode in that we're using a very fast serial connection between the two servers, really the two sides, the trusted and the untrusted domain. But we still guarantee the one-way connection with no possibility to get network connection back and basically bring malware or anything unwanted into the trusted network. So we still maintain the full protocol break, and that only allows data transfer from one direction. So that's really the purpose of NetWall. Now, if you look at NetWall, the common application would be data transfer using, for example, Windows file share or FTP servers. And in that case, we have what we call the blue server on the trusted side. You would be scanning the data source, either it's a file share or an FTP server. When there's a new file in this location being inserted, it would actually read the file, would do some inspection, make sure the files is actually the desired file type. So you can really restrict what type of files you export. And of course, we're not going to look at the extension. We're going to look at the content of the file, at the payload. And we can also inspect it for malware. And when satisfied, it meets these conditions, then the data gets moved to the red server on the untrusted side. And the red server would actually move the data to the destination, either another folder in an FTP server or another Windows file share. So that's really the use case for file transfer. If you're looking at Modbus replication, the blue server actually has a Modbus client. So you can configure data sources. What are the data sources? What kind of points do you want? Registers, discrete registers, etc. What frequency do you want to read them? And in that case, we would, the blue server would read all these data points, push them across on the red server. And the red server is actually a Modbus server. So now only allowed clients would be allowed to be reading this data on this red server Modbus server, and the data are just available at the disposal of the Modbus client on the untrusted side. So that's done all in real time, and we can push tremendous amount of data. For OPC UA, it's very similar. We have our own application built into the blue server. It connects to an OPC UA server. We do the full replication of a server, and we push it to the OPC UA client on the other side. We can deal with, we can load your certificates for encryption, so that we maintain the same level of, we keep the keys active on the other side. We have a gigabit connection between, up to a gigabit connection, so there's no, there's no issues transferring that, and that's really the key application, right? OPC DA and AE replication as well. For OPC AE and DA, we have a small application. Bayshore created a small application that typically runs directly on the OPC server and on the OPC client on the other side. But if you don't want that, we can run them on interposing servers, and that's what the representation architecture here. But typically, you do not use an extra server. You put the software directly on the OPC server and OPC client. So now it's time to show you the demo environment. So I'm going to switch to sharing my other screen, which is much bigger, because unfortunately, I really have to show you the source and destination at the same time. For you to see what is going on. But really, what I'm going to show you today, just because of the time-ish situation, I'm going to show you the network console, which is used to configure the system, and then show file transfer using FTP and Modbus. Just in the lab right now, the last thing we did is a full ignition HMI server replication, where you have a whole ignition server running on one side, then you have OPC UA going to the ignition server on the other side. But for today, I really want to keep it simple, and I want to show you how very easy it is to configure these devices. So bear with me for a second. I need to stop sharing and transfer the share to the other screen. Okay. Hopefully you can see my screen here. So what we have is we have a trusted side. We have a server on the trusted side with my OPC server here. And we have the other machine on the other domain on the other side here. And here, this is actually the console. So we have the network application, which is used for management of a device. The servers do not have any web interfaces. They don't have any SSH access or anything to configure them. All the configuration is done from that side on the trusted side. And we only communicate with the blue server. There's no need to make any kind of configuration of the red server. It's all done through this application. Out of the box, out of a factory, the networks have a default address, IP address, and we use that server on the Windows application to go talk to them and modify that IP address to the desired, environment. You can see here 101.173. You can set up the DNS, etc. if needed. And the red server is also configured from the blue side, and the configuration is pushed to it, to the red server from the blue side from this application. So everything is done from here. From here, you can see you can set up a FTP, a file exchange, Windows file share, and we can actually do that in a very simple way. For example, if I look at FTP, this is what I'm going to concentrate today. We just set up your users, your password, what is the file, the file you're sharing inside this FTP server, and we have the ability to actually restrict some files. Which files do you want to block? And you can basically block everything except Microsoft Excel spreadsheet if you wanted to. In this case, only thing I am blocking, I'm allowing everything except Windows executable to go through. Okay. So that's really simple in terms of configuration. And I want to show you the configuration also for, you update the software that way, threat intelligence. You can do the Modbus configuration. You see here now we are running, we are reading 9 registers every 500 milliseconds and pushing that across. It's really, and you can really add, you can double click on modify, but I could actually, you can see the kind, we're only doing reads, obviously. And we can actually add as many points as you want from here. The same thing for OPC UA configuration, very simple. Okay, we do everything from here. We can just go modify, load our certificate, import server certificate, etc. as needed. And we do the full replication of the UA server on the red side, and just really have to configure the port and the server statistics. That's it. So that's really, we try to make the configuration very simple. We also have the ability to have streams of UDP or TCP streams going on. For example, here we have a syslog stream through UDP. We can also do any type of, any type of UDP stream, that's simple, but also TCP stream. We will replicate the freeway handshake. However, there is no ability to get data coming back. So only a few protocols will work well that way. But for example, we can do syslog through FTP. MQTT-TN allows to have unidirectional, actually we're using UDP. So, we can really do any kind of these streams, and this is multiplexed. So that means this device allows you to do OPC and Modbus and file transfer on any of the streams as well in parallel, all multiplexed through the system with a single device, if that makes sense. So now, time permitting, what I want to do is a very simple demo. I'm gonna copy some files. So that's my blue FTP server, that's the source file here. I'm gonna copy a number of files. And if you note here, actually I need to make that bigger because I want to show you, I've got a 0-byte file. So if you look at the policies, the executable files should not be copied across. They'll be blocked. And the 0-byte file is also not gonna be copied across because it's 0-byte. So per policy, we're going to block Windows executable, and also by default, we also block 0-byte files. So I'm putting that in my source folder, and what I want is have these files appearing here a short while later. So there's a task which is looking at the application that's been found, that's been read by the blue server, being analyzed, then pushed to the red server, and then the red server is going to copy these files into the destination, which is this folder here. There you go. So now you see we have less files than before. The 0-byte file didn't get transferred, and the executable file have been blocked. And you can actually go to this application here, and you can look at the event. You can do network events. We're looking at Roadrunner, and I'm looking at file transfer, and refresh, and it will tell me the event here. It's going to see that the 0-byte file you're going to see out of policies is going to find this in here. So that's again, the idea is to be a device which is transparent. People are not meant to get tasked and read data all the time out of it. There must be a lot of data here. But the idea is really just to be a device which is working, transferring the data, and we'll let you know if the data are not arriving, if there's any issues. So you can see, okay, the items have been successfully transferred. And if I look at errors, you know, these are not working. So it's telling me all the things that have been refreshed successfully, refresh complete. And, you know, it tells me what these exe files have been going through. So that's really what I wanted to show in terms of NetWall. But we also have actually in the background here, we are sending some UPC, some OPC, we're sending some OPC UA and DA. Actually, I have time to show you a quick Modbus application. So actually, I've got this little Modbus application. You can see the Modbus TCP, and you can see the source of this is 222.74, which is our red. Let's go back to unilateral. That's going to be the red server. I guess I need to close that window first. If you look at the red server, it's 222.74. So my OPC source is the red server, and I'm going to go read holding registers. And what we're reading is actually just a clock on a dongle number, and that's actually connected to the, if you remember the graph I showed earlier, this is connected to the Modbus, actually the OTFuse. OTFuse has a Modbus server built in, which is showing not only the clock and the status, etc., but also showing if there are any events, how many events, and source of the events, and also the time of the last event. So we actually have a Modbus server built in, and what I'm using here as an event going through the network system all the way back to the Modbus client here on this side. So we're showing that, you know, it's pretty much in real time. The delays are really minuscule. It's really, really fast to go across. And this is what we want to do. The system exists starting at 50 megabit per second, 100 meg per second, and gigabit. This is really, the hardware is the same, so it's field upgradable by license. And if somebody needed something faster in the lab, we have a system working at 10 gigabit. But in this case, we need slightly different types of hardware, so we have not made that as a part number available, but if somebody needs it, we've tested it and it works well. I think that will conclude the portion of the demonstration I wanted to do today. I want to let Volodymyr probably carry on, or if you have any questions, I'm willing, you know, I'm taking any questions you may have now. I just wanted to make sure that I was sharing the overall architecture. When you can see, you know, the OTFuse protecting at the cabinet level, and the NetWall, which is there to export data out of a plant in an untrusted environment, whether it's this is the corporate network on IT, or a customer, or a supplier. We need to send information regarding the you know, good functioning of a plant. Thank you. Okay, how is Besho ensuring that NetWall is operating only one way while using Ethernet wires? Okay, that is a good question. The key answer here is there is no Ethernet connection between the two servers. It's a PCIe serial connections. So we definitely have a protocol break between the two. We're extracting the data, and the data are being sent through a serial connection to the other servers. So there's no way to get a return path. In terms of internet technology, there is special cards we're using in the servers, and they are shared memory on the red side. And there's really a data segment where blue is pushing data. The blue server is pushing data into the red server using this data segment on the red card. And there's also a small area for signals that blue and red are using to share. And we can go through the details if you want of the architecture of the data transfer there. But there's no way for the red server never send data to the blue server. It's always blue pushing the data and reading a few signals. And if you actually, I can share that slide if you want. And there's really no way to get a return path that way. Yeah, so if you look, and that's really going to be a key difference with a data diode, is that we're sending the payload from blue to red into this data segment here, and there's a status segment which is used to update on the status. So that, for example, if you have a TCP stream and the source is sending a reset, you've got your destination, you're sending a TCP stream from blue to red, and the destination on the untrusted network sent a reset signal. So it's sending a data reset to the red server. The red server will put that in the status segment. There's been a reset, so that blue can reset the initial connection so that the source can reinitiate a new TCP connections to go all the way through. So again, it's not a TCP connection going all the way through. The TCP connection all ends on blue. We move the data across on a new connection gets started from red, but there's a status going through here. So what it means is we have no GUI on red. There's really no TCP ingress, but there's no listening ports on red. The only port open is what is needed for the function. So if I've set up a TCP server on red, because I've got TCP client here, obviously I'm going to open port 502 or whatever is configured. Doesn't have to be that particular port, but by default we have no port open on red. And in the worst case scenario, if somebody was getting a root access to the red server, there's no way to send data into the blue server. Even the configuration gets rewritten. The configuration of red, we are sending it back. I think every 5 seconds we update the configuration here. So the worst that could happen if somebody had root access is that they would do a denial of service. It would not be possible to send files or data across, but they would have no ability to send data into the blue servers. The worst that they could do is putting gibberish into the status segment. But the data we've got here are pretty much hashes, which already are pre-calculated by blue. And we're just making that the hash, we know what it means. Everything is run in memory. There's no access to disk or anything like that. So there's really no way to get data through, if that answers the question. If I can find the chat, there was another question. There was a second question. The second question was, is it possible to connect OT-Fuse tap device to 2.4 wire RTUs? No, not directly. The OT-Fuse device is a Ethernet device. It doesn't have RS-232 or 485 directly. So you need to use a converter from, for example, Modbus RTU to Modbus TCP. That was a question earlier. Thank you very much for these questions.